Fuel system failures are becoming one of the most expensive out-of-warranty repairs we've seen in recent years. High-pressure fuel pumps, direct injectors, carbon buildup. These failures rarely happen overnight. They're slow-motion breakdowns that begin years before a check engine light ever flashes. The gap between modern precision and old-school maintenance has become a canyon. So today, I'm going to break down how modern fuel systems actually work, why they're more sensitive than older engines, and the strategy I use to help customers like you reach 300,000 miles while most people are trading it in at 120. Think of an older engine like a garden hose. Low pressure, around 40 to 60 psi. Wide spray pattern. A little contamination doesn't immediately stop it. That's port injection. Fuel sprays behind the intake valve, mixes with air, and actually washes the valves every time it fires. Now compare that to modern direct injection. Modern systems operate between 500 and over 3,000 psi. That's not a garden hose. That's a pressure washer. Fuel is compressed by a mechanical high-pressure pump, often driven by the camshaft, and sprays directly into the combustion chamber through microscopic injector openings. The benefit? Better efficiency, more power, tighter emission controls. The cost? A much smaller margin for contamination. Companies like Bosch help drive this technology forward. It's incredibly advanced. But precision systems demand precision maintenance. These engines aren't fragile, they're exact. And exact systems don't tolerate dirt, deposits, or neglect very well. Your car doesn't fail immediately when something drifts out of spec. It adapts. The engine computer monitors airflow, oxygen sensors, throttle input, engine speed, and then it constantly adjusts injector pulse width to maintain correct air-fuel ratios. That's where fuel trims come in. Fuel trims are simply the computer making corrections. If an injector begins to clog slightly, the system doesn't panic, it stays open longer. If pump output drops slightly, it compensates. Your car can actually compensate its way into long-term wear. By the time you feel a hesitation or see a warning light, the system may have already been straining for tens of thousands of miles. Our goal isn't to wait for it to break. All right, now that that's out of the way, let's get practical. Picture yourself standing at the parts store staring at a wall of 50 different bottles promising a tune-up in a can. Before you spend a dime here, we have to talk about what you're putting in at the pump, because that's your baseline. All gasoline contains detergents, but fuel that meets the top tier detergent standard contains significantly higher detergent levels designed to prevent injector deposits before they ever become a problem. Stations like Exxon, Chevron, Shell, and even Costco participate in the top tier program. If you're using top tier fuel most of the time, you've already done more than most drivers do to protect their injectors. That's step one. Now we can talk about the bottles. Not all fuel system cleaners are created equal. Some are mostly carrier solvent. They might offer light cleaning, but they don't contain that high temperature detergent chemistry modern direct injection engines actually benefit from. If it doesn't contain PEA, polyethylamine, it's probably not doing much inside the hot combustion chamber. Real PEA-based cleaners help remove injector and combustion chamber deposits because they survive combustion temperatures. Products like Amsoil PI or the ones made by Liquid Moly or Redline use that chemistry also. For most direct injection engines, running a quality PEA cleaner once or twice a year is solid preventative maintenance. I tie it to oil changes because it's easy to remember. Every tank, that's just burning money. Now let's talk about something completely different you'll see on the shelf. Intake cleaners like this Seafoam top engine cleaner and this CRC GDI intake valve cleaner. These are not for the gas tank. These are designed to be sprayed into the intake tract, past the mass airflow sensor while the engine is running. It can be smoky, it's aggressive, and that's normal. That smoke is a mix of cleaner and softened carbon deposits being burned off through the combustion cycle. Like we talked about earlier on a GDI engine, fuel sprays directly into the combustion chamber. It never washes over the intake valve. That means the dry side of the intake valve sees no detergent wash. Only oil vapor from the PCV system and blow-by gases slowly baking onto the surface. If you want to chemically address intake valve carbon without tearing the engine apart, this is what you use. If you've got a GDI engine, doing an intake cleaning every 10,000 to 20,000 miles is real preventative maintenance. If you wait until 100,000 miles and it's already misfiring or idling rough, now you're looking at a walnut blasting service and it can easily run $600 or more at a shop. If you're not comfortable doing it yourself, pay a professional, but don't ignore it. Now let's talk about one more category in this aisle, upper cylinder lubricants. Here's the unpopular truth. Modern gasoline already contains lubricity additives. Fuel pumps and injectors are engineered around today's fuel chemistry. Most upper cylinder lubricants are oil-based. They're essentially introducing additional light oil into the combustion process. But here's the issue. A turbocharged and direct injected engine, oil contamination is already one of the primary contributors to intake and combustion deposits. PCV vapor and blow-by gases are a major source of carbon buildup. Engineering research around GDI engines consistently points to oil intrusion as a contributor to deposit formation and particulate output. So when you introduce additional oil into a system that's already sensitive to oil-derived deposits, you're increasing one of the variables engineers are trying to control. Most modern engines don't need extra upper cylinder lubrication. Now let's talk strategy. Here's some tips you can use today to help your car get to 300,000 miles. Number 1, use top-tier fuel consistently. Not sometimes, consistently. The higher detergent package prevents injector deposits before they even form. Prevention is always cheaper than a teardown. Run a real PEA-based cleaner once or twice a year. If the bottle doesn't contain polyethylamine, don't bother. It's the only chemistry that survives the combustion chamber to actually clean. I tie it to oil changes, it's simple, and it works. Clean the intake valves every 10,000 to 20,000 miles. If you have a GDI engine, fuel never touches the intake valves. If you ignore this, those valves will eventually look like they're covered in charcoal. And next, watch the oil spec and the NOAC score. Modern engines need the right specs to fight LSPI, which is low speed pre-ignition. That's why we have API and DEXO standards, but you also want a low NOAC score. NOAC measures volatility, or how much oil evaporates under heat. That oil vapor travels through the PCV system and bakes onto your intake valves. A lower NOAC score means less glue for the carbon to stick to. Under 10 is preferable, 6 to 8 is optimal. Number 5, follow the quarter tank rule. Your in-tank fuel pump is cooled and lubricated by the fuel itself. Running near empty increases heat and friction. Consider a quarter tank empty. Get it filled up and save yourself a fuel pump replacement. Next, change your serviceable fuel filter. If your vehicle has one, swap it. Pumps hate fighting restrictions. Don't let a clogged filter burn it out. The 7th tip is don't ignore long crank times. If your car starts taking longer to fire up, that's usually an early warning sign of pressure bleed down. Most modern cars compensate quietly for a long time before they finally throw a code. Listen to the warning. Number 8 is skip oil-heavy upper cylinder lubricants. Modern fuel already has lubricity additives. Adding extra oil into a deposit-sensitive engine doesn't help. It just adds more unburned residue into the carbon mix. Stick to chemistry that cleans, not chemistry that coats. Number 9, stop excessive idling. Low load, low temp operation is a carbon factory for direct injection engines. If you aren't moving, you're just baking gunk onto your valves. And last, give it the Italian tune-up. Once in a while, let the engine get fully warm and do some real work. These engines are designed to operate in a specific thermal window. High cylinder pressures and temperatures can actually help burn off light soft deposits before they harden. Use these tips consistently and you're on your way to 300,000 miles. I'm going to drop this list in the description. Fuel system repairs are expensive because they involve precision components. High pressure pumps, direct injectors, carbon cleaning services. But most of these failures aren't lightning strikes. They're the result of slow and neglected maintenance. The difference between a 120,000 mile disposable car and getting to 300,000 miles isn't luck, it's intention. If you wait for the light, you're reacting. If you maintain the system before it complains, you're winning. If this kind of breakdown helps you think differently about ownership, hit the subscribe button. I'm Chris from Beachside Auto Parts. I'll see you on the next one.